These are the frequently asked questions for pre-calculus for the review that we're using for sections 5.4, 5.5, and 5.6. And all four that you've asked for are dealing with proofs or simplifying and using all of the different formulas that we have to reach a conclusion. So number 3 says, in exercises 3 and 4, simplify the expression to a single term and support your answer graphically. I'm not going to worry too much about supporting this graphically, but what I want to do is see what can be done to this in order to simplify it. And while I was writing it out, I'm thinking of two things. First of all, I know that's in one of the formulas, 1 minus 2 sine squared theta. And so, especially on the test, you're going to grab that sheet and you're going to think, okay, where is that 1 minus 2 sine squared theta? And it won't take you very long to find it. That is the cosine of 2u, which is, in this case, the cosine of 2 theta. So this would give us the cosine of 2 theta squared. Now, we go to the next piece, and we say, okay, 4 sine squared cosine squared theta. Hey, wait a minute, the 4 doesn't fit, but I know that it's 2 sine theta cosine theta that uses the double angle identity, so that's the sine of 2u, or in this case, it is going to be the sine of 2 theta, but we've got that 4 in there. So you think, well, where did the 4 come from? Well, it came from the fact that this is really 2 sine theta cosine theta squared. And that makes us realize, all right, so far we've got this cosine of 2 theta squared, and now this 2 sine theta cosine theta is going to be the sine of 2 theta squared. So now it comes down to, do we understand that when you have the cosine of some angle squared plus the sine of that same angle squared, it doesn't matter whether or not it's 2 theta or 3 theta or 4 theta, that's a Pythagorean identity, and that is 1. Cosine squared theta plus sine squared theta is 1. So the angle itself doesn't really matter. The fact that the ratio of those sides is always going to come out to be 1 when they are squared is what matters. So there's number 3. So notice what I did was I just looked at the problem and thought, I've seen this somewhere. You know, where is this? Which formula uses this? And then once you work forwards from that thinking, that logic, eventually you start to see, oh, I can do this, and oh, I can do this, and just keep going with it. So number 5, this one says we're going to prove this identity that the cosine of 3x equals 4 cosine cubed x minus 3 cosine x. And I'm actually going to start with the side that looks easy. That looks like it's the simplified side right now. But the reason that I'm going to use that side is because I know I don't have any formulas for cosine 3x, and I realize what I'm going to have to do is use the cosine of 2x plus x to make that happen. And looking at the right-hand side of this, I realize I can use the formulas here to manipulate and get a lot of things from cosine of 2x plus x. So the next place to go would be to use our formulas that we had for adding those cosine angles. And that pattern again was cosine, cosine, sine, sine. But with cosine, if we are adding the angles, we have to put subtraction in there. So this will be cosine of 2x, cosine of x, sine of 2x, and sine of x. So now comes decision time, where you think, okay, I'm always going back to what I need here. I need cosine cubed x. So what I'm going to have to do is replace that cosine of 2x with something that could potentially be multiplied by this cosine x to give me cosine cubed. And there's two choices here. And the other thing that I think about as I'm looking forward is that I notice in the second part of this, there's no sign. And so something's going to have to happen back here to get those signs to cancel out. So if I do end up with a sign in the front, that probably wouldn't be a bad thing because it may just cancel out with something with sign in the back. So I'm going to use cosine squared x minus sine squared x. And that comes from the double angle identity. And I'm going to take that times the cosine of x, because again, what I've just accomplished is I'm going to be able to get that cosine cubed x that I need. But now in the back, again, I'm thinking this has to go somewhere. You know, this sine of 2x, it's not going to help me out a lot, so I use my double angle identity of 2 sine x cosine x. And I have to take that times this sine of x. So let's see what we end up with here. If we distribute this cosine of x from the right-hand side, we'll have cosine cubed x minus sine squared x cosine x. And then in the back, we'll have minus 2 sine squared x cosine x. Now, like I said before, we notice, wait a minute, something pretty good just happened here. This will give us cosine cubed x, but if we have minus sine squared x cosine x, and we're going to subtract 2 more sine squared x cosine x, now I have minus 3 sine squared x cosine x. All right, so now back to what I need my answer to be. My answer needs to be 4 cosine cubed x minus 3 cosine of x. So our next step is to figure out something that we could substitute in for this sine squared x so that everything in this problem would become cosine. Well, I'm going to leave cosine cubed x alone. And just think for a second here, and I'm going to reverse this and make this cosine x so that when we distribute this, this will go nice and easy. I want to replace sine squared x with something that just has to do with cosine. And I realize that if I grab any of our power reducing identities, well, that would be one way to go with it, but then I'm going to have 2x back in here again. And nothing in my answer has 2x for the angle, no double angles. So I'm going to give 1 minus cosine squared x, just using the good old Pythagorean identity there. Give that a try and see what happens. So cosine cubed x minus 3 cosine x, and this is by distributing the negative 3 cosine of x, plus 3 cosine cubed x. And now I have 1 cosine cubed x plus 3 cosine cubed x, which is 4 cosine cubed x minus 3 cosine of x. And there it is. There it is. Now, let's just say that at this point, you accidentally use one of those power reducing identities. You're going to notice that things are starting to stray. You know, you should be getting closer to your answer at this point, not farther away. So maybe you take a step or two and you realize, wait a minute, this isn't working. Then you go back and say, all right, I needed powers of cosine in order to make this work because my original problem said this was going to come out to 4 cosine cubed of x. And then go back and hopefully you'll be able to use that Pythagorean identity to get it. Number 8, this one we have again prove the identity, and so it's a matter of choosing which side you want to work with here. And with this one, I'm actually going to go with the left-hand side. You know, as I look at that, 2 sine theta cosine cubed theta plus 2 sine cubed theta cosine theta, I'm thinking we could get that down to sine of 2 theta at some point. So I'm going to go ahead and start with the more complicated portion of this time. All right. So I need that to come out to be the sine of 2 theta. So let's see here. First thing I notice is this is factorable. When I was writing this down, there was a 2 in both of these terms. There was a sine of theta in both of these terms, and there was a cosine of theta in both of these terms. And hopefully, as you see that, you're thinking, oh, wait a minute, that's one of our double angles there. We can have a formula for that. So let's see if we factored that out, what we would have. We would have a cosine squared theta plus sine squared theta. Ooh, things are working out very nicely here. So starting with something bigger, wanting to get to something smaller, and the first thing you think about is, gosh, can I get any of this out of here? And the way you would do that would be by factoring. So we've got our little 2 sine of theta, cosine of theta, and this is, of course, 1. That's our Pythagorean identity. And then we look at that and say, wait a minute, that's our double angle identity for sine. So this is the sine of 2 theta, and you're done. So starting with a more difficult section, in this case it was the left-hand side, you have to think, how am I going to get this smaller? You know, what could I simplify that would make that happen? And factoring, especially when you notice that you're writing the same thing down twice in those 2 terms, can really get you there quickly. Number 9. Well, this one I don't really like, you know, and again, this is one of those where we're using those secondary trig functions. So the first part of taking care of this, because I don't like working with those secondary trig functions, is to just see what this looks like in terms of our primary trig functions. So cosecant is what you get when you flip sine. Oops, too many C's. So we've got cosecant of x minus cosine of x cotangent of x. And the reason I'm going to start with the more complicated side on this one is, again, my hope is that once I see what's going on with the primary trig functions, that things are just going to drop out, and we're going to get sine of x. So, pardon me, cosecant, 1 over sine x, the reciprocal of sine. And then we have cosine of x, and I'm just going to slap that over a 1 because, again, I'm trying to see what's going to cancel out as far as my secondary trig functions go. And then cotangent is cosine of x over sine of x. All right, so now I take a look at this and say, all right, these would have a common denominator. I mean, this is going to be 1 over sine of x minus cosine squared x over sine of x. So if they have a common denominator, let's see what happens when we put them together. Put those numerators together on the top. So we'd have 1 minus cosine squared x over sine of x, and even if your memory is really short, you're going to be thinking, wait a minute, we've used this stuff with the Pythagorean identity at least 2 times in the process of these last few problems. And of course, one of those is going to cancel out, and we're going to get down to sine of x. So those are some methods to use, some thinking to use as you're working through these proofs, or simplification of identities.